Greetings and salutations. In today's video, we're going to be discussing measuring speed and acceleration. So, when discussing this topic, we have to keep in mind what motion is. Well, motion is happening around us every day. It's movement. For example, when you place a DVD to play, it spins in a circular manner. This is called circular motion. And say for another example, you're playing a guitar, and those guitar strings are called a vibrate motion. Say you are on a train traveling from A to B, that would be called linear motion. Well, it's basically the motion is in a straight line. Now with speed, a simple definition of speed is the rate of change with respect to time. Now with velocity, the simple definition is the rate of change of displacement with respect to time. Now in simple terms, it's basically the change and speed of a direction. The acceleration, though, is the rate of change of velocity with respect to time. Now this is how fast the velocity is changing. This triangle is very important when discussing this topic. There are three factors: distance, speed, and time. Now, there are a few ways to remember this. One that is quite common is Dunn Store's trolley. You can use really whatever, but we have to consider their units. So this is a list of their units. So say you are given the time and speed, right? What's left is distance. So whatever two factors, the time and speed that you're given, you must multiply to get our distance. But our distance needs to have a unit, right? So our unit would always either be meters or kilometers, okay? Now say you are given the distance, and the speed, right? And you're left with the time. So with the distance and the speed, you would have to divide to get the time. And when you do get the time, your unit has to be in seconds or hours. Say you're given the situation where you are given the time and the distance, but you need the speed. So then you would divide the distance and the time, and the speed would either be in minutes/seconds, kilometers/hours. Now with the slash, if you don't really like how it looks or you don't really prefer it, you can just say ms -1 or km hr -1. So instead of distance, they would use the word displacement, okay? So with displacement, it's literally just distance, but they are just calling it displacement. Simple as. So let's get a practice question. Say you are given the question, okay, distance is 10 meters, okay, and the time is 5 seconds, okay? So we're given our distance, we're giving our time, and we need our speed. So what must we do? We must divide. So to get speed, so you're doing distance divided by time. You must always write your formula. So our distance is 10 all over 5, which is 2. Now, with this, we are given meters and seconds, okay? So we can either choose to do meters/seconds or meters seconds -1. I'll just do meters/seconds, okay? Simple as. You're given that distance is 1.8 kilometers and time is 1 minute, okay? Do we see a problem? Because I do. With this, we are given distance and time. We need the speed, okay? The units are in kilometers, okay? So we look, there's either meters or kilometers. It has to be either or, okay? We're given kilometers, so we're like, okay, so the time needs to be in hours, but the time is in minutes. So that's a problem. So there are two things we can do. We can convert this 1 minute into hours, and then the unit would be perfect, kilometers and hours. Or we could change this. Since we know that time is 60 seconds, we would have to convert kilometers into meters too. But let's do that. So if you don't know how to convert different measurements, go check out my other video about making accurate measurements. It's in the description below. So to convert kilometers into meters, you would have to multiply this by 1,000. So 1.8 multiplied by 1,000. So that is going to equal to 1,800 meters. So now we're given the distance in meters and the time in seconds. So we know that this unit, well, the units, they match. So then we can find out the speed. The speed is distance over time. So our distance is 1,800 all over 60, which is 30. Now with our units, meters slash seconds. Okay, perfect. And you don't need to square the unit. You can just leave it as it is. And that's it, really. So then, now for a little bit more of a deeper explanation of velocity, right? Say you are given, say there is this triangle. Anyways, so say you're given this triangle, right? Looks quite weird. This is point A, this is point B, this is point C. So say from A to B, okay? From A to B, your speed, okay, is the same, okay? So let's just say your speed is 50 kilometers per hour. Let's just say that, okay? But from B to C, okay, B to C, we're going to travel at the same speed, okay? And let's see if it takes the same amount of time. Now, from A to B, it took, let's just say, 30 minutes. Okay? So then from B to C, right, our speed, let's use the same speed, okay, would be 50 kilometers per hour, okay? And then this also took us 30 minutes, okay? Perfect. But then you're told to find the, then you look at C and A, okay? And you're like, all right, so C and A, it tells you, say you go right at the same speed. You're like, all right, so 50 kilometers per hour, but then that ends up being 1 hour. So this is a change in velocity, right? And you could go, all right, instead of using the same speed, you could try the same amount of time. You could be like, all right, I'm going to get there in 30 minutes, but you end up using the speed of like 100 kilometers. So that's kind of what velocity is. It's the change of speed and direction too, right? And remember the different types of motions. How I mentioned, for example, circular motion. So, and it would just be going in a circle on and on and on and on, right? But say you change the speed and you go the opposite way, right? Say you go the opposite way. In this case, and you change the speed, this would be a change of velocity. Simple as. You don't really need to overthink it. Say you're given another question, right? And it's a bit more complicated, and you're told the displacement of a train, right? The displacement of a train is around 2,345 meters, right? And you're told the time is 315 seconds. Find the velocity. It's not the same as speed, but you can manipulate it to use it the same way, all right? Hear me out. So, your speed, right, is distance over time. But we're finding the velocity. So with the velocity, we can divide these by seeing the change in speed, right? Which is what velocity is. So distance over time, we can find, but this isn't what it is though. Speed is the actual amount. This is just determining the difference of, okay? So distance over time. So that would be 2,345 all over 315. So then this would be 7.4 meters squared. And that would be your answer. say you are asked to find the acceleration, all right? So in this case, the acceleration is always in a straight line, okay? It is in a conversion, you would use accelerate to refer to an object that is increasing in speed. Now, to find the acceleration, the formula is the final speed, take away first speed, all over time taken. So it's kind of like just the time taken for the change in speed. Now, acceleration is about the rate of change in velocity with time. Now with this, the unit of acceleration is meters/second squared, all right? Or if you don't want the slash, it'll be meters second minus 2, all right? Simple as. So say you are given the problem, okay? A car is moving at the speed, okay, so the speed of 4 meters/seconds. And then after 12 seconds, it is moving at the speed of 28 meters/second. Now it's telling you calculate the acceleration. So this is your speed, right? But the thing is it's the first speed. At the start of the question, it's telling us that this car at the start is moving at 4 meters per second. And then after a certain amount of time, the speed has changed to a different speed. Now it's telling us to find the acceleration. Has the acceleration increased or decreased? And that's what we have to find out. So the first speed is 4 meters per second. The second speed is 28 meters per second, right? And the time they have told us is 12 seconds. So now with our formula, final speed take first speed all over time. So final speed, so second speed, final speed, same thing. So 28 meters per second. Take away 4 meters per second all over 12, which is 24 all over 12, which is just 2 meters squared. So the acceleration has increased by 2, but not always would it be increasing. Sometimes it can be decreasing. Say you are given the problem, a train's first speed is 50 meters per second. So the first speed is 50 meters per second, okay? And the train is traveling for the time of 14 seconds. And when it gets near to its destination, its final speed is 8 meters per second. So now with our formula, we can find the acceleration. So our final speed is 8. Take away our first speed was 50. And our time is 14, okay? So this would be minus 42 all over 14, which is equal to minus 3 meters/seconds squared. I forgot, squared. Don't forget your units. So we can see the contrast between the first and the second question. In the first one, it is increasing by 2, but in the second question, it is decreasing by 3. And that's perfectly fine. There's nothing wrong with it. So that is that. Thank you for watching.